Hi, my name is Mushfiq Mohammad Fahim. Currently, I'm studying at Department of Computer and Communication Systems Engineering at University Putra, Malaysia. My metric number is 231148. Today, I'm going to run an assembly in order to execute a program where the arrays of data is given, and we need to get the average of the data and store the result in the variable called result. All right, let's get started. So this is our assembly code. First, we need to set up the memory. Actually, we need to build first. Build. Here it says build successfully. Now we need to set up the memory. All right. Our variable is data. Hexadecimal format and word. Array size is 4, and lastly our result variable. Sorry, result. Array size 1. So we have two sections in our code. The first one is text section, and the last one is data section, and we have declared our variables array at the data section here, and the main code is here, the main function. We initially used the instruction move EBP register, move the ESP register into the EBP register, so the both will have the same values. As a result, it will be uh, easy for us to debug. So here is the two different addresses for the EBP and the ESP. So we want this to be same. So we given the instruction move EBP comma ESP. So our ESP and the EBP become the same. And now we will initialize the accumulator. So we will initialize the accumulator to 0 for our accumulator become clean, as it shows that we have 0 in our accumulator. And then we'll set our counter. We have set counter to 4 because we need to add 4 words. So our counter is 4, ECX to 4. We have instructed the ECX to become 4. Yeah. Now we have instructed the segment index, instructed 8 into the segment index because we want to get offset to 8. So where is ECX? ECI is 8. And yeah, for this part is this label is for the loop. As we set our offset to 8, this index will be used to access our words from the array. So we have decrement the ESI 2 times, because like from decremented from 8 uh, 2 times for each iteration, because we want to access the words in the array backwards. For first iteration, the iteration will continue up until the condition is reached. Our condition for the loop exit is until our ECX here reaches 0. So the, for the first uh, for the first loop, it will continue because here ECX is not equivalent to 0. And for the second loop, we got two datas added from our array. Now rest 2. Here the last data will be added after we completed the loop. Here, as you can see, the ECX reached 0. The condition is met. As a result, it jumped out of the loop. Now we need to clear the EDX register. For x86 assembly, we need to clear the EDX register before division, because to get proper result, we need to clear the DX register. Otherwise, it will interfere with the EX. So we're going to set the number for the sum of 4 numbers. So you need to divide with 4 to get the average. So now we will divide. Now our result got stored in the accumulator, and we want to store it in the variable result. So now it got in stored into the result variable. So here, as you can see, our result is 2800, which is correct result. And for the system Linux call, we need to put 1 into the accumulator, and we should call the kernel to exit the program successfully. Alright. As you can see, we can't see any output here. So in order to get a proper output, we can write an instruction print. As we're dealing with the hexadecimal format, we're gonna use hex, print hex, the size, and the variable result. So in order to execute this instruction, we need a library. The library will be include io.inc. Alright, now if we run the program again, and now we do want to print the result. As you can see, our result is 2800, and after completing this instruction, we will be able to get the result, printed result, in the output section. Alright, let's go. Here we can see the result which got printed 2800, and finally similarly the system Linux system call to exit, and finally executing terminating the program successfully.